give a little update of where we are and where we're going now. So I've got about a dozen of the blanks here made for the key plugs, and we're going to make some more, but I stopped after that because I wanted to go ahead and get on with the second part of the project. I've still got the lathe set up, and we're going to crank out however many we can get out of that piece of bar stock I've got over there. I'm estimating I'll be able to do about 25 or 30 of these out of the stock that I had. But anyway, the next step is to mill this this little wedge into the side of this. And again, as we talked about before, according to the drawing and according to the measurements that I've made on this, this angle is 76 degrees. So the angle from 0 up to here is 14 degrees, and we need to be able to mill that on there. And to do that, I need to come up with a little jig to hold these at the proper angle in the mill. So what I've got here are just some pieces of aluminum, and I'm going to make a set of soft jaws to go into one of my vices. And we're actually going to come in here with a 7/8 inch end mill. I'm going to set it up on the milling machine where this will be at a 14-degree angle like this. And we're just going to basically come into the top here, plunge straight down in there at that angle, and create a void inside these soft jaws that will hold this piece in there just like that, and it will clamp down, and when it does, we'll be holding that piece at the right angle, or the correct angle. It's not a right angle, that'd be 90 degrees. But anyway, we'll hold that in there, and then we can just put these in there and go over to the mill machine and run them out. So the first thing I need to do though is get these jaws ready to go into my mill vise. And there's of course some little screws here that's going to go in here, and these need to be drilled in the proper place, and then we need to counterboard them so that these will actually go down inside these soft jaws. And this is a 5/16 18 screw that goes in here. So the first thing I need to do is actually position or find where those holes need to be on my vise. And I know from past experience on this vise, from having made one of these before, that these holes are not at any normal distance apart from one another. I've measured them, they're both different. They're not set on exactly like 4 inches or something that you would expect. So instead of trying to do it off of a measurement, what I'm going to do is I'm just going to use some little punches, and I've got these little kind of transfer punches, transfer screws in this case, that I can screw into the hole in my vise, and then we'll actually find the actual center for these. So let me show you what we're talking about with these. I don't know if you've ever seen these or not. This is the actual vise that we're going to be using, and I've taken the steel jaws out of these and just set them aside. We're going to, like I said, make a new set of soft jaws. And what I'm going to do is these little transfer screws, they're threaded on one side, and they have a little center punch, basically in the exact center of them on the other side. This little hex on there is just so you can put something on them to screw them in and out. You can put a little wrench on there, but we're going to just go ahead and actually put these in place on the vise itself, and we'll put all 4 of them in there. All right, with the transfer screws in place, the next thing I'm going to do is we'll kind of tighten this up to about where it needs to be. I had it wide so I could get my big fat hand down in there. All right, that's close. And I don't know if you can see it in the video, but there's actually a little step in the bottom of both these vices. It isn't quite flush with the bottom. And so these jaws actually do not ride directly on the bottom. They're up just a little bit. So what I'm going to do is I've just got some parallel heres that I use in the mill, and they're really about the same height up as those, and I really don't care if it sits exactly on that step or not. I just want them up a little bit higher. And so we'll put those under them to kind of support them in place. I'm going to get these jaws kind of centered up where I want them, and we'll just squeeze this together. Let me get a wrench and we'll tighten that up, and we should have our holes positioned. Before I take these out, I'm going to mark where they go. Just call this one left and right, and that's just an arbitrary marking for me to make sure I get them right back in the correct place. Loosen those back up, and you can see the punches marks there where the holes need to be drilled, and I'm just going to now go over to the drill press. We'll drill these out just on the drill press and then counterbore those with a counterbore. I've got this set up on the drill press now, and we just got some parallels up underneath here and a vise that will move back and forth. I'm not too worried about it having a real rigid on here. I'm trying to just get into these centers, so I want to have a little bit of movement. And we're just going to punch these through. This is a 5/16" drill bit, which should let that socket set screw go right through. Little drill press drilling tip, in case you don't know this. I think most people probably do, but I'm sure some of you don't. But when you're drilling, you get these big stringy chips coming out, and if you let them get real long, they'll kind of get up here and flap around, and they can really get dangerous. You have to stop and the drill and clear them off. But having worked in a machine shop where I literally drilled thousands and thousands and probably 10,000s or 100,000s of holes, if you just kind of peck this thing, go down a little bit and just barely let up on the, and I'm exaggerating this, but barely let up on the pressure, you'll break that chip. And what will happen is you'll let it come up, you'll break it, and it'll just kind of fall off. And that's one way to keep from getting those long, stringy shavings when you're using a drill bit or drill press. The next step I want to do is we want to actually put a counterbore in here, because we're going to put this socket cap screw in. We've got the hole there, but I want to recess this head down inside of the piece of material here and get it down in there a good little bit. And to do that, I'm going to use a tool here called a counterbore. And this is a special tool that's made specifically for countersinking socket cap screws. And these, the ones that I have here, are made the right size here. So if you look on here, it's basically like a drill bit, or like an end mill, I guess more correctly. It's ground flat on a step here on the bottom, and then this down here is just a pilot hole, and it's going to follow a hole that's already drilled. So in this case, this is an exact fit to go down inside that hole that we've got, and I can kind of scratch on there, and you can kind of see the diameter that it's going to counterbore, and that diameter is just right for that head to fit down into. So we're going to get this set up, and we're going to set the drill bit, or drill press, so that it's only this counterbore will go down to a depth deep enough to bury that socket cap screw in there, and then stop. And we want those to be about the same depth. So we'll go ahead and get that set up now. All right, the counterbore should be ready to go. And we'll just follow that hole all the way down. All right, there's the bottom. You saw that pecking action that I was using there, again, to kind of control those chips. And anyway, now that set screw goes down in there, and bottom's on the bottom, just what we want. got the first jaw in place, and now we're going to put the second one in here. Alright, so now we've got some good soft jaws in place here on the vise, and we'll get this set up on the milling machine and make our little jig. I've got the vise over here on the vertical mill now, and we're going to go ahead and get this vise trammed in so that we can create our jig in here. And I'm just using my last word indicator, and I just want to indicate back and forth here across this back jaw and get it lined up. So I've got it come in here, and you know, this thing, I just take about half the travel out, put it on 0, and I put it over here on this edge, and get my auto feed going here, and then we're just going to move the vise to the other side. Alright, so across that, what is that, 6-8 inches, whatever that is, you know, we're about 5/1000ths out. So just to kind of show you how I got to where I am now, I have not done anything to adjust the vise yet. That 5/1000ths is just right out of the block. And the way I did this, when I bolted this down, I've kind of got my bolts just snugged in here, and I pulled it up tight against the bolts on the back, and then tightened it down just a little bit more. It's still where I can bump it around, but it's not loose enough that I can just, you know, if I just touch it, it's not going to move. But I can take a hammer or something and bump it around. So I'm off 5/1000ths, and what I want to do is I want to actually try to get to my indicator. I'm going to move it around. I'm going to pivot it. Since I am working off of this corner, I'm going to try to pivot on this bolt here. So I'm going to try to tap it on this side. Oops. And take it back to 0. And it's wanting to pivot on this side. So we're going to have to go back to the other side now and do this again. So we'll start off by zeroing it again. Alright, so we're at about 4/1000ths. And try to bring that to 0, and we'll go back to the other side and see where we're at. All right, that looks pretty good. I've got about a 1/2,000ths over the length of those jaws, and I'm gonna call that good for what we're doing here. So now we're gonna tighten down the vise real good, get it, make sure that it's good and snug. And after we have tightened it, I wanna run it one more time just to make sure that in the process of tightening it, we didn't move it ever so slightly. All right, so we're about 1/1000th out, and we've got some irregularities in here. I'm seeing that needle jump around a little bit, and that's just because this is not a ground surface. This is an extruded piece of aluminum, and I'm working off that surface that's in there. For what I'm doing, that's not going to matter, because we're really just going to be drilling a hole in here and using that hole that we're going to drill. So we just need to get it pretty darn close, and I think 1/1000th of an inch over those jaws there are going to be more than adequate. We're only going to be milling 3/4 of an inch, so we've got it set up real good here. Soft jaws are in the vise is mounted to the table, and one thing that I noticed when I did this is that the tops of these jaws are not perfectly parallel with one another, and you know, we drill these holes out, we put them in here, and that's not unheard of. Now the thing is when I come back and put this back together, if I ever need to reuse these jaws or this jig that I'm about to make now and use again later, I want to be able to reference these to make sure that they're in there exactly right. So what I'm going to do is I'm going to take a few minutes and we're going to actually mill the top of this flat and the sides of these square, mainly just so that, again, if I ever decide to use this jig again, I'll have some surfaces that I can use to get these lined back up exactly right again together down the road. I've got the face mill in here, and we're just going to real quickly face across the top of here, and all I'm trying to do is just get it cleaned up all the way across to have a good reference surface to work off of. All right, we should have all these surfaces nice and trued up now. I'm just going to do a quick deburring here, get any of those sharp edges off of that. All right, that feels good. And that'll give me plenty of surfaces to reference off of should I ever need to set up to do this job again. And now we're going to go in here and put in our recess in here to hold the part. I will mention that I was using that long reach 7/8 inch end mill to do this. It probably would have been better to have one a little bit shorter, wouldn't have as much vibration in it, but I already had that mill out because I'm about to use it for another job here, this next step, and that's the reason I was using that. Now that we've got everything cleaned up and flush, and we can put this back on here again if we want to, I want to find the edge of this back jaw here and get it on center with the center of the mill here, because we're going to bore a hole in here that's going to actually need to be in the very center of these jaws. So I'm going to use an edge finder for that, and this is just a little edge finder. It's got a little spring in here, and it kind of wobbles around, and you can find the edge of that and then get your center. We'll bring that up, bring in the back jaw, and when that bottom part kind of jumps over, it's perfectly parallel with the edge of that edge finder right there. And what I'm going to do is I'm going to zero out my DRO. And I usually like to repeat this, so I'll go in here and just do that one more time. And my DRO is on 0, so we're going to go with that being the center of the edge. This is a 1/2 inch in diameter, so we'll come up and now again using my DRO, I'm going to move my vise in 250 thousandths, and we will be on the edge. Right there. Again, let's kind of talk about the strategy of what we're going to do here. So we're going to come in here, we're going to reset this mill so that it's coming in here at an angle and boring a 7/8 inch diameter hole in the vise there, that we can clamp this piece in here, and that at the right angle to mill it off. But to do this, I don't want to just pull my vise jaws up real tight and drill that out, because I want to make sure that when I close them up that I'm coming in good contact with the part itself. So what I want to do is I want to actually leave just a little bit of a gap in between these two soft jaws here when I bore that hole in or drill that hole in. So what I've decided to do is I've got just a scale here. I've measured this. This is 40 thousandths of an inch thick, and what I'm going to do is I'm going to put this down in the bottom, which is well below the area that I'm going to drill into, and we're going to close the vise up. We'll tighten it up, and that should leave a 40 thousandths gap in between the two jaws. So let's just tighten that up a little bit. Not super tight, but tight enough. And so right now I've got the center of my quill here, or of where I'm going to be boring, right on the center of the back jaw here. Because that's 40 thousandths, I actually want to move the table out, so basically the center of this gap is in the center. So I'm going to move that in another 20 thousandths, and again I'm just using my digital readout to make this measurement. And right there it should be the very center of that gap, and we're going to lock or re-zero the DRO. We'll just lock the table down right there to bore that in. So that now we have this on the very center of that gap in between there. So we want to tilt the head over to this angle that we need, which is about a 14-degree angle coming up here off of the part. And so I've already loosened the bolts on the back side. There's 4 bolts on this milling machine that kind of hold the head in this axis. Whoops. So I want to loosen all 4 of those. Like I said, I've already got the other ones on the other side loose, and I just want to loosen those up enough that this will move. And I've got a whoops, let's go the other way. I've got a little ratchet on here, and that's got a worm gear in there that will move that around. Hopefully I got enough cord there to go as far as I need. The angle we're going for here is 14 degrees, and the way I'm going to do this is we're just going to use some angle blocks, and this is just from a standard set of angle blocks, and I've got a 10-degree angle and a 4-degree angle that I'm putting together to get the 14, and we're just going to lay that up on there. I've extended my quill out to give me a good reference measurement area, and I'm just going to eyeball this and get it kind of close, and then we're going to raise that table up against the quill. Hopefully that'll have enough room to come up. Alright, so we need to come on some more down with the angle. Bring the table up some more. So we're getting real close here to run this thing down and making this jig. So again, just to kind of clarify in case you're not following what's going on, obviously we got the angle set to that 14 degrees. I'm going to take that down. So this is one of the key plugs that's already milled, and you can see there's that flat on there. That's that wedge that will go up into the piece and wedge the holder for the knives in place. And so we've got to hold this part at this angle in here. So the idea is I'm going to bore this hole through there, and what I want to do is I want to get the outside edge of this just below the surface down here. So it's going to be way down in here somewhere by the time that goes down, and I just want to get it barely below the surface, because you can see that right here, that leading angle kind of comes right flush with the edge of this. So I want that just to be, in the bottom is actually just a little bit deeper, so I want that to be just a little bit below the surface. And I think if we would do that, that'll give us a nice area to clamp this in. So we're going to go ahead and drill this in. I've got my 7/8 end mill all tightened. Everything I think is ready to go, so we're just going to go ahead and push that through. We've got all this vacuumed up now and cleaned up. Just a couple of comments. Number one, this is a center drilling end mill, so I wasn't worried about leaving any gaps in there or not being able to go all the way down. So if you're going to be doing a boring operation like this through solid material, you need to have center drilling end mill. And I did pretty quickly decide to go over there. I had some aluminum Tap Magic cutting fluid here, and anyway, I went and grabbed that, and that helped a bunch in cutting this. It's not even hot, which is good. So anyway, I haven't done anything except just clean it out. Like I said, vacuumed it, blowed it out, and I got my blank, and it slides down in here. That is exactly why I wanted to have this little gap in here, because I figured that I was going to get just a little bit oversized with this end mill, and I wanted to be able to clamp it down later. So I've got 40 thousandths in there that I can clamp on, so that should not be a problem that it's sliding down there. It's not super loose in there, but it's not tight. The other thing I'm going to do is just take my deburring tool and kind of go around here and just try to relieve that sharp burr on there. So that doesn't cut me when I'm putting this in there. It's still kind of sharp, but I don't think it's too bad. All right, let's see if it'll clamp. All right, get my scale out of there. Tell you what, I'm gonna open that up and deburr that on the inside a little bit. All right, I think we're ready to go now. All right, hopefully that should hold that in place now, and we can just skim across the top of that and mill those flat. We'll have to do this one at a time. You can see how much room it's taking up on this block here. I was hoping I could get 2 of them in there, but that's not going to work out. So, we don't have too many of these to make, so we'll just do these one at a time. We'll take a second to mill those off on the mill. So I've moved my vise over, and I'm going to actually do this milling operation on the horizontal mill. I could do it with the cutter on the vertical mill, set straight up. Would not be a problem, but again, I like using my horizontal mill, and this is a perfect application for doing some milling on here. So what I've got in here now is we've got this set up. I put my vise back over here on the horizontal mill. It's bolted down, clamped down. I wasn't too worried about getting it trammed in just perfectly because we're just basically milling a flat top. It really doesn't matter what orientation this vise is in because no matter how I mill it, that top is going to come out flat. So I didn't go to the trouble of tramming the vise in for this particular job here. Again, you know, a lot of times people, anytime they put a vise on, they're going to tram it in, and I tend to look, when I get through this job, this vise is coming right off. It's not going to get used again on this setup. So I decided not to spend the time doing that in this situation. I've got just a spiral cutter on there. It's about 3 inches in diameter. I think I counted 16 teeth on there. Doing some calculations, I determined what my speed needed to be, and I kind of, on my last horizontal milling job, some guys questioned my speeds and feeds. And a lot of times, I'll be honest with you guys, when I'm doing this, I get it set up and I just kind of run it based on what I'm comfortable with. But on this one, I've got this little speed and feed calculator. It's a little slide rule thing. And, you know, I put in the diameter of my cutter. I knew how many, you know, using, so that was a 3-inch cutter. I determined what my surface speed I wanted using the chart on the back here, and for steel. Anyway, I'm shooting for about 100 surface feet per minute on there. And based on that, I find 100 on here, and it tells me what RPMs. It said it needs to be about 160 RPMs. And I've got this set up on 153 RPMs is what my mill has, so I'm right there close to it. And then on the feeds, this thing is calculating a pretty fast feed rate, and I'm sure the mill will take it. But I slowed it down a little bit to 2 1/8 inch, and part of that has to do with the fact that I noticed that I've got a little bit of run out in this cutter. It's not much, but you can hear it when it's cut, and it's cutting, and that's also very typical of a horizontal mill. It's very difficult to get one of these cutters running just absolutely perfect. And so by slowing that feed down, I'm getting more hits of that high spot as it's going across there, and I'm going to end up with a smoother finish. So right now I'm running on, I think 2 1/8 inches per minute is what I've got this set up on. And again, the feed rate could be higher. I'm not in a hurry. You know, if we were making hundreds or thousands of these parts, you know, we may be trying to get a little more efficiency out of the setup. So I've got my blank here. The chamfer end goes down. It just goes down into that recess, bottoms out on the bottom. And we tighten the vise up on there good and snug. Now that's holding it in. Notice too that I've got this feeding in a direction where the pressure is sliding it down against the stop in there. You know, if we were coming the other direction, the pressure on this would be pushing the part out. I want to be pushing the part down, seated up against that piece in there to make sure that it doesn't go anywhere. So we're ready to go. Let's fire up, and we'll make a pass on this. All right, there's the finished part. That just took a couple of seconds to mill off. We'll blow that out. and remove the part. Alright, there's the finished part. That just took a couple of seconds to mill off. We'll blow that out and remove the part. And that part is finished. You can see got a real nice finish on there, nice and flat across the top, and got that angle just like what we want. I'll probably take these and hit them with a Scotch-Brite wheel, just polish them up a little bit, knock any burrs off. We'll put the set screws in, and these parts will be finished. I'm just going to run a few more of these now and knock out the ones we got. And that part is finished. You can see got a real nice finish on there, nice and flat across the top, and got that angle just like what we want. I'll probably take these and hit them with a Scotch-Brite wheel, just polish them up a little bit, knock any burrs off. We'll put the set screws in, and these parts will be finished. I'm just going to run a few more of these now and knock out the ones we got. We've got all of our parts milled on the milling machine now. I got the flats on there, the angle piece. So So this job is pretty much done. I still need to take these home, and I'm going to use my Scotch-Brite wheel on my grinder at the house and just kind of polish them up, make sure I got all these edges deburred real good, and still need to put the set screws in these. And I've got the set screws, and it's just a matter of running them all down in there. I'm going to wait and do that until I get them deburred though, and these will be ready to go. So I bought a piece of 7/8 inch cold roll steel, which is what the drawings called for as far as the grade of steel, and 36 inches long, 3 foot long, and I got 37 key plugs out of that 36-inch piece. And of course there's a little short piece over there left that's just too short for me to continue gripping onto. There's probably enough material there to make another 2 or 3 if I could grip it. But it's you know, you always run into that when you're doing bar stock on a production job like this. You get down to the end and you have some little scraps. All in all, I'm pleased with the setup here, how everything went. My jig here on the mill worked real well. This operation here went real quick, at least compared to turning the pieces over there. Not that these took a long time to turn on the lathe, but the milling just went really quick. And man, I can't say it enough. I just love a horizontal mill. This thing cuts through steel just like butter. And you can really do some heavy milling with this thing, and particularly on a production setup like this, it's the way to go. I can do this much faster on the horizontal mill than I could on the vertical mill, and really end up with a much nicer finish on here as well with this type of cutter, and with the speeds and feeds that I was able to use on here. So this job is about done. A little bit of bad news. Ever since I got this mill, and I guess I've had this mill now about 2 years, but ever since I've got it, it's had a little issue with the rapid traverse on it, where the clutch feels like it's slipping, and I have tightened up the clutch in this thing several times. It's a fairly simple process, and it just seems to be getting worse and worse and worse. The more I use it, the worse it seems to get, and I was really having some trouble with this, where that clutch is slipping, particularly when I'm in rapid traverse mode on this thing. So I really don't know what's going to take to get that fixed. If any of you guys out there have any experience working on these Kerner Trekkie milling machines and have any suggestions, I'm all ears. You know, my fear is that I'm going to probably have to tear into the knee on this thing and figure out what's going on. And I really don't want to do that, but that may be what I have to do. If I do have to tear into this thing, I'm probably just going to strip it down and just do a total restore on this milling machine. You know, that may be my next project, is working on this milling machine if we can't figure out this rapid traverse. So if anybody's got any suggestions, by all means let me know. And with that, we'll sign off and talk to you guys next time.